Okay, so today we're going to continue with matrices, and we're going to do Gaussian elimination. This is named after a mathematician with the last name of Gauss. Okay, and then we're going to identify matrices that are in the form REF and RREF. So that stands for row echelon form and reduced row echelon form. So right now we do not know what those mean. By the end of today, all will be revealed. And we'll also be practicing some of the same concepts from yesterday. Okay, so this Gaussian elimination has most of the same steps as what we did yesterday. There's just a couple more additional steps, which makes it easier for us to solve. Okay, so a matrix is in row echelon form if it satisfies the following conditions. I'll just apologize in advance that I can type this up for you. So the first non-zero number in each row, and you don't have to write reading from left to right, okay, that's implied, right? Okay, so the first non-zero number in each row is 1, and this is called the leading entry. Okay, so that leading entry has to be a 1. Okay, so you can just say the first matrices, the first non-zero number in each row in those matrices is 1. Okay, this is called the leading entry. Okay, the second thing is the leading entry in each row is to the right of the leading entry in the row immediately above it. Okay, so the leading entry in each row is to the right of the leading entry in the row immediately above it. Okay, and we're going to look at some examples of this. And then sometimes we're going to get rows that consist entirely of zeros. Those are going to be at the bottom of the matrix. Okay, so if you have a row of all zeros, that has to be at the very bottom of the matrix. I'll put that up on the board today. Okay. So a matrix is in reduced row echelon form if it is in row echelon form, so it satisfies all of those above conditions, and then there's just one more condition, okay? And that is that every number above and below each of the leading entries is a 0. So yesterday we only had to do the zeros below the leading entry of a 1. Okay, so we had to get the zeros below. Today, we want zeros above and below. Okay, so we're going to observe those matrices and we are going to say what form it's in. Okay, so reduced row echelon form, every number above and below each leading entry. So the leading entries are the 1s. Every number above and below that is a 0. Okay, so I want you to look at the matrices below. There's 3 matrices below, and we're going to label what form it's in. So if it's in row echelon form, REF. If it's in reduced row echelon form, it's RREF. Okay, and then it might not be in any of those forms at all. Okay, so let's take a look at those. Okay, so the first thing we're going to do, I like to highlight where the 1s are. So you should have a leading 1 in each row. So in the first row, it's here. In the second row, it's there. And then I have 1 here. Okay, and then this is the leading 1. That's why I'm going to highlight that. So the leading 1s do not shift to the right. Do you see how in this row it's to the left? That's why it's not in REF form. Okay, and if it's not in REF, it can't be in RREF. It can't be in the reduced row. Okay, so this does not satisfy condition number 2. Okay, so condition number 2 says the leading entry in each row is to the right. So because this one is to the left, it definitely is not in reduced row echelon form. Because I just highlighted the leading 1s, so the leading 1 is just going to be the first one. All right, now if we look in the second one, so this is a leading 1, this is a leading 1, and this is a leading 1. Okay, so the leading 1s do shift to the right, and below them are the zeros. So this is what we call row echelon form. And that is what you did yesterday. You just didn't have a lot of diversity in the matrices you see. So this satisfies conditions 1 through 3. Okay, and then in order to satisfy all the conditions, what would this one have to have in order to be in reduced row echelon form? Yeah, it has to have the zeros above it. So condition 4 is having your zeros above it, above the 1s, and above this one we have a -6. Above this one we have the 4 and 10. So these two would have to be 0, and this would have to be 0. Okay, and then the leading 1s for the last one. We have a 1, a 1, and a 1. So the leading 1s have zeros below it and above it. Okay, it doesn't matter for this one because there's no leading 1 here. Okay, and then a row of zeros is at the bottom, so we're good. All right, so this is reduced row echelon form, and it satisfies conditions 1 through 4. Okay, and again, that is because you have the zeros below, you have the zeros above and below there. Okay, so that's when you have that reduced row echelon. Okay, so we can put a matrix in a row echelon form using those elementary row operations that we used, that we talked about yesterday. Okay, so we're gonna convert a matrix into reduced row echelon form, and I'm just going to teach you a systematic way to do that. All right, we're math people, we like having a system, we like following rules, so this is going to help you with that so that you won't get as frustrated when you're trying things on your own. Okay, So we're going to start by obtaining a 1 in the top left corner. Okay, or is it okay if I call it A11? Remember that means first row, first column from yesterday? First row, first column. Okay. Then we're going to obtain zeros below that 1 by adding appropriate multiples of the first row. Okay, so we're going to be multiplying something by R1. Okay, and then we know from yesterday that we can add that to the rows below it. Okay, now when you want to obtain a leading 1 in the next row, to obtain the zeros below that 1, you are going to keep using multiples of that row. Okay, so you're going to obtain a leading 1 in the next row and then zeros below it. I'm going to show you how you can multiply so that you don't mess up what you've already done. And by that, I mean when you get the 1 and 2 zeros, we don't want to mess up the zeros we've already had when we go to the next row. Okay? All right, so you're going to continue this process until your matrix is in row echelon form. Okay? When you're doing this, just make sure that at each stage, every leading entry is to the right of the leading entry in the previous row. Okay, and then if you need to rearrange the rows, you can. Sometimes that's quicker. So this is showing you how this might work for a 3 by 4 matrix. So the first thing that you would do is get the 1 in the upper left-hand corner. Okay, and then you get the zeros, and then you get this 1, and then you'll get the 0 below it. Okay, and then you'll get this 1 here. So it's very similar to what we did yesterday. Once you have this 1, 1, 1, then it's in row echelon form. Okay, so that is exactly what we did yesterday. Right? So when you have an augmented matrix in that row echelon form, we can solve the linear system using back substitution. So that is what we did yesterday, and that technique is called Gaussian elimination. In honor of its inventor, the German mathematician C.F. Gauss. Okay, so this is just a review of what we did yesterday. When you're solving this system, the first thing you're going to do is write the augmented matrix. So that's just rewriting those coefficients. Then you're going to get this in row echelon form, so using elementary row operations, and then you're going to do back substitution. Okay, so this is what we did yesterday. We just didn't put that name to it, and all the problems I gave you yesterday, you already had a 1 as your leading value, so you didn't have to do that part. Today it's going to be a little bit different. All right, so I want you guys to do the augmented matrix. That's always your first step. You can put it right here. I always like to do this in pencil. So when you're doing your augmented matrix, we're going to want like 3 rows here, just so you know. Okay, so when you're doing the augmented matrix, you're putting in the coefficients. So the coefficient of x, the coefficient of y, the coefficient of z, and then your constant. Don't try to scrunch them too much together. You guys know how to do the augmented matrix, so do that. You don't have to look at mine, right? So don't be nervous. you did your notes yesterday? Okay, so then what I was saying is I don't want you to feel like you have to scrunch these together because I do feel like it makes a difference if it's organized. Okay, if it's not as organized, then it's easy to add the wrong things together. So then we have 7, 14, 5, negative 10. Last row, negative 6, 1, 58, negative 51. Okay, that is your augmented matrix. So the first thing we need to do is we need to make this 11 into a 1. The first thing I would do is look at these to see if any of those are a 1. If they're not, the way that we get a 1 quickly is to multiply by the reciprocal. So we would take the first row and we would just multiply that by 111. And if you're multiplying, you don't have to say that it's going to row 1. We know that it is. Okay, and don't be scared. Look how nice this is going to be. So it's 1, 2, negative 1, 2. Okay, and then I want you to write your other two rows for me. Okay, so after you get that 1, now you have to get the zeros below it. Today we're going to do that. Let's do it in one step, okay? Okay, so to get those zeros below it, you have to multiply by the opposite. Okay, some of you don't have the next two rows right now. We need to do that. Right, because you just have, these two rows are the same. We didn't change them, so they're the same. Okay, so for row 2, we want this to be a 0 now, okay? So if we want that to be a 0, all we have to do is multiply by the opposite. So the opposite of 7 is negative 7. So we'll multiply row 1 by negative 7, add it to row 2, and that can be our new row 2. Okay, and if that's our new row 2, that means this is going to be the same. So I want you to do the row 2. And then we're going to talk about our other options. Okay, so then there's a couple different things you can do here. Now, when you did this, what do you notice happens with the first two values? What did you get for both of these? Yep, 0, 0, yep, and then 12 and negative 24. Okay, I'm nervous that I see some of you just copying that down. So it's a negative 7 plus 7 is 0. Negative 14 plus 14 is 0. 7 plus 5 is 12. Negative 14 plus negative 10 is negative 24. Okay, you guys with me on that? Okay, so the next thing that you can do is see how you have the 2 zeros and you really want 2 zeros here. So if you wanted, you have a couple options here. You can multiply by 6 and then add this here. So multiply row 1 by 6, add it to row 3 to get that 0. Or what I recommend for this is that you flip row 2 and row 3. And it's okay that we ran out of room here. You still need to do this part, but then you can put this new matrix here. And this is not always going to happen, but because you have the 0, 0, 12, negative 24, and here you have the negative 6, 1, 58, negative 51, do you see how you also have a leading 1 here? So this is just going to be less work for you, okay? You don't have to do it like that. Okay, so now that we did that, we're going to have to get a 0 here. So we want this to be a 0. So you always multiply by the opposite of this row above it. That's how you can make sure that when you add those together, okay, you don't mess up what you've already done. So if I multiply this by 6 and add it, I'll get 0. That's what I want. All right, so I'm just going to write row 1. I'm going to write row 3. And you're going to calculate row 2. All right, so guys, keep going if you're done, okay? So 6 times 1 is 6. 6 plus negative 6 is 0. 6 times 2 is 12. 12 plus 1, 13. Negative 6 plus 58, 52. 12 plus negative 51. What do you guys get? 39, right? Yeah. Yeah, so 12 would be negative 41. Okay. All right, so now the next thing you want to do is get what, where? Yep, so what are you going to do? Yes, multiply that row by 1 over 13. And again, don't be scared. This is a nice one as well. Because you should get whole numbers. That's not always going to happen. I said to stop tweeting. Okay, so 52 divided by 13, do you guys know what that is? 4. Yep, and then negative 39. negative 3, and then this is so beautiful. Our last step is to make this into a 1, so what are we going to do? 1 over 12, we got lucky again, and oops, I don't need another. Oh, sorry, do you guys have a question for this? Okay. So then, when you multiply by 1/12, it's 0, 0, 1, negative 2, 0, 1, 4, negative 3, 1, 2, negative 1, 2, okay, and then this is in REF. Okay, once it's in REF, we are going to use back substitution to solve, and I think I gave you room on the next page to do that. I gave you a lot of room. Okay, so we're going to use back substitution. Hi. Oh, and we took England's okay. Okay, I let me run it down. Okay. Yes, I think they're both both for that. Thanks for reminding me. Okay, thanks. Bye. Okay, so I want you guys to do the back substitution. So remember, this is x, this is y, this is z, this is your constant term. Okay, so I want you to take all three of those and write the equation, and I'm going to keep mine up here so you don't have to flip back and forth. You can just look at this and write your system down. Okay, so when you're writing this out, I'm a little nervous that some of you did it on a different page. Okay, so all you're doing is you're taking that equation and you are writing it out in terms of x, y, and z. Okay, so were we able to do that okay? So the first thing you have is z is negative 2. Okay, and I gave you a lot of room. And then you have y plus 4z equals negative 3. Oh, it's right here. Z equals negative 3. Right? Because here you had negative 24. Okay. Okay. And so y plus 4 times negative 2 is negative 8. So if this is negative 8, we're going to add 8 to both sides. So then y is 5. And the last one is x plus 2y minus z equals 2. Okay, so then you have x plus 2 times 5 minus negative 2, which is going to change into plus 2. Okay, so if this is x plus 12 equals 2, then you're going to subtract. Why did some of you not do this? Okay, and then how do we write our answer? Yes, as a coordinate. So negative 10, 5, negative 2. Now, whenever you get this coordinate, you can plug it back into the original equations and make sure that it works. Because if you plug it in and it does not equal 22 for the first equation, or negative 10 or negative 51, okay, then that is not the right solution. That lets you know that you made a mistake. Okay, so that is what we did yesterday. We did that Gaussian elimination. It's row echelon form. Now the cool thing about reduced row echelon form is we don't need to use back substitution. So if we put it in RREF, then we don't need to use back substitution to solve. Okay, and in order to do this, we are going to first put the matrix in REF. Okay, then we're going to obtain zeros above each leading entry by adding the multiples of those rows containing the leading one. Okay, so we're going to multiply the row with the leading one, and then we're going to add them together. Okay, and then when we do that, it's called Gauss-Jordan elimination. Another fun name for us. Okay, so if you're solving with a system in reduced row echelon form, Gauss-Jordan elimination. Okay, this is what your final step will look like if it's in RREF. Okay, so if it's in reduced row echelon form, look how nice this is. This means x equals some number. They just put that blank box there. This means y is equal to some number, and this means z equals some number. That's why we don't have to do the back substitution anymore. It'll already be solved. So what we're going to do is we are going to take where we left off in example 1, that REF matrix, and we are going to keep going to put it in RREF. Okay, so the first row is 1, 2, negative 1, 2. The second row that we had was 0, 1, 4, negative 3. And the third row was 0, 0, 1, negative 2. Okay, so what we're going to do now is we are going to get the 0 above. I want you to think about how we can make this 2 into a 0. And if you think you know what we're going to do, just write that rule down here. Yep, so if you're just coming in, just jump in with us. Make sure your device is okay, so we talked about how you're always multiplying by the row with the 1 in it. Okay, so if you're trying to make this a 0, in the same column, this one has the 1. So what are we going to multiply by here? What did you guys come up with? Yep, times. Yep, and then we're going to add that to row 1, and then that's going to go in row 1. Okay, this can be a tedious process, so it's important that your focus is here. So if that's going to replace row 1, sometimes what I do is I'll just I know I'm only replacing row 1, so I'll write the other 2 rows down. Right, so the nice thing about this is a 0. So negative 2 times 0 is 0. 0 plus 1 is 1. Negative 2 plus 2 is going to be 0. Again, make sure you're keeping them in organized columns. Okay, and then negative 2 times 4 is negative 8. Negative 8 plus negative 1 is negative 9. Negative times a negative is a positive. 6 plus 2 is going to be 8. Okay, and now our next step, we have 1, 0, 0, we have 0, 1, 0. Okay, our last row should look like this, where you have 2 zeros and then the 1. Okay, so in order to do this, we're going to use this leading 1. So if this is in row or column 3, you're going to use this row 3 because this is your leading 1 value. Yep. So we want this to be 0, so we'll do that first. Okay, so think about what you, how you want to do that. Okay, and then write that down here. You always want to use a multiple. Okay. All right, so once you figure out what you're going to multiply by, you're going to multiply 9 times row 3. We're going to add that to row 1. We're going to put that in row 1. Okay, and then if you do that, I like to put the other 2 rows here just to keep myself organized. Okay, so if you do 9 times 0 plus 1, you get 1. So 9 times 0 plus 0 is 0. 9 times 1 plus negative 9 is 0. 9 times negative 2 is what? Negative 18 plus 8, negative 10. So how do we do? Okay, so then we have one more thing to do, and that's to make that a 0. Okay, so can you see if you can write the rule for me? All right, so you always want to multiply by this row if you're trying to get zeros in this column. So we're going to multiply negative 4 times row 3. We're going to add that to row 2, and that's going to be our new row 2. And since we're making a new row 2, that means row 1 stays the same. Row 3 stays the same. Okay, and then I'm ready to multiply. So negative 4 times 0 plus 0 is 0. 0 plus 1 is 1. Negative 4 plus 4 is 0. And then negative 2 times negative 4 is 8. 8 plus negative 3, 5. Okay, and what I'm saying out loud to you is what I say to myself in my head when I'm doing this. Okay, so I do step by step. Like I said, this is easy to make a small mistake on. So this is in reduced row echelon form. And the great thing about that is you can just look at the top row and you know x is negative 10. This is in the y column. So y is 5. Z is negative 2. And then you don't have to do the back substitution. Okay, so yes, this is the same answer we got above because it is the same matrix. We just went one more step. Okay, and then I am going to show you this, just not today, but there's a function on your calculator where you can double check to make sure they're in the right form. I know you guys will be nice and sweet, so I'll share that with you so you can check the work quickly. And then your chapter 10 test is going to be next week. We're going to take it in 2 parts. And there's going to be one part where you can use a calculator and one part where you can't. So just make sure that you are using it responsibly. Okay. All right. And then the last thing we're talking about is just some special cases here. So inconsistent and dependent systems. So all the ones that we've looked at have had exactly one solution, but a system can have one solution, it can have no solution, or it can have infinitely many solutions. Okay, so the row echelon form of the system allows us to determine which of those cases applies, and they outlined it for you in this information box. Okay, so if there's a no solution, then the row echelon form has a row that represents the equation where 0 equals a constant. Okay, and if you have 0 equal to a number, that's not a true statement. So this is called an inconsistent system. Okay, and then you have one solution.
Taking the AP Environmental Science exam are released from class. Please report to the biking room.
Okay, and then make sure you guys get your notes done tonight. Okay, and then you'll have some homework as well. Okay, so if there's one solution, that's what we've been doing. So if each variable in the row echelon form is a leading variable, okay, then we can use back substitution or you can use this Gauss-Jordan elimination. Okay, and then the last one is infinitely many solutions. And if you have infinitely many, the system is called dependent. Okay, it's going to have infinitely many solutions if you have a row of zeros. Okay, so if it says if they're not all leading variables, okay, then you have infinitely many solutions. So we're going to look at that. So if you have no solution, it's 0 equals a constant. If you have infinitely many, you end up with 0 is equal to 0. Okay, so the leading variable in a linear system is one that corresponds to a leading entry in the row echelon form of an augmented matrix. Okay, and then the matrices below are all in row echelon form. They're going to illustrate those cases. So we're going to label each one. So this first one here, this equation says 0 equals 1. Do you see how there's no 1 here? Because this is like your x, your y, your z, and then the constant. So the last equation says 0 equals 1. Is that true? No. So that's when you have no solution. If you have 0 equal to a constant. Okay, and we call that inconsistent. There's no solution. Okay, and then for this one, it says each variable has a leading variable here. So this is what we've been doing. The x plus 6y minus z equals 3. The y plus 2z equals negative 2. And then z equals 8. See how we can solve this with back substitution here? Okay, so then that means there's how many solutions? 1. Okay, and then the last one, you have this row of zeros on the bottom. This is telling you 0 equals 0. Okay, and there's no leading variable, right? Because there's no 1 and there's no constant here. So this is when you have infinitely many solutions. Okay, so earlier we talked about if we have a row of zeros, it has to be at the bottom. Okay, and when that happens, you should have infinitely many solutions, and we call this dependent. All right, and then colors, but I want to make sure it's the same one as how